This is our video explaining how to do the questions in the second part of lesson 3. So we're jumping in at example 3. Example 1 and 2 were done in class yesterday. So we have this question where a manufacturer is producing calculators and the number of calculators that are being produced are X, and the cost to produce the calculators is represented by this equation, and each calculator is sold for 60 minus 0.05x. So we want to figure out the value of x that maximizes the daily profit. So the first thing we have to do is figure out an equation just to represent profit in the first place, and then we are going to use calculus in order to try and figure out the optimum value of calculators that we can sell. So the first thing we're going to remember is that profit is equal to revenue minus cost. So in our example, revenue is going to come from how much, if we remember that revenue is the amount of money coming in. So if we sell X calculators and we sell each calculator for 60 minus 0.05x dollars, that will tell us how much money we have coming in, and then we're going to subtract the entire cost function. So we're going to subtract this entire function from the revenue. So we could write here just C at X, but I'm going to go ahead and put the entire equation in there. We could proceed with the equation exactly the way it is, because what we have now is actually an equation for profit, but because the simplification at this step is simple to do, we may as well do that to make the following steps a little bit easier. So we're going to go ahead and expand everything out and group all the like terms, so we have the fully simplified version of this equation. The next thing we're going to do is try and figure out the value of x that maximizes the daily profit. And if this was a previous grade before we learned how to do derivatives, we could answer this question. We would look at this as a parabola and try and figure out the coordinates of the vertex. And the x coordinate of the vertex would tell us the maximum profit, would tell us the x value, that the number of calculators sold to give us the maximum profit, and the y value would give us the actual profit. So we could do that, but there's a faster way now that we have calculus, because we can figure out where the vertex is very quickly. All we need to do is find the derivative of the profit function, and because it is a polynomial, finding the derivative is very straightforward. And then we're going to set the derivative equal to 0. The reason we're going to set the derivative equal to 0 is we want the maximum, and at a turning point, the slope of the tangent will be 0. So setting it equal to 0 will give us that critical number, or that maximum, for this situation. So we're going to take the derivative here, set it equal to 0. And we're going to get approximately 666.7. So that's giving us the x value for the number of calculators we should sell. So we figured this out. What is the value of x that maximizes daily profit? And then finally, we want the price for maximum profit. So all we have to do is plug that back into this price equation. To get a price of $26.65.